Hey, PBS. It is for you guys going to be Thursday, April 16th when you see this, or within a day or so, depending on your schedule. I'm filming this on Wednesday morning, the 15th. And just want to touch base with you guys first and give you a little facial contact, at least to me, so you see that I'm still here, still doing, and still hoping that you guys are doing okay. As I'm keeping up on some of the work that you guys have been doing. Love to see that you're staying on top of it. I hope things are clear, understandable, and that they're getting done without ridiculous amounts of time. So I hope through you guys doing the survey a couple weeks ago that you have seen some slight improvements to some of your frustrations with the class. If anything is still not running right for you or something is confusing to you, please, guys, do not hesitate to reach out to me via remind message or via email. I'm happy to hear from you, and I'm happy to clarify and work with you so that we can make sure that this year continues to be a good one for us and that we finish it on the right foot next month. I'm up on the Schoology page, the daily posts that you'll see from me. I just wanted to touch on a few highlights, and then I'll get going with a little information for you guys about EKGs. We got to talk a little bit about the heart and the electrical activity of our heart. Your announcements are all you're going to have to work on for me for this post for Thursday, April 16th, is part 2 of 4B3, which is the EKG assignment. That will not be due for you guys until Monday evening, 10 p.m. So you'll have between Thursday, Friday, Saturday, Sunday, or Monday to pick when you want to sit down for, gosh, I can't imagine more than an hour total to knock that assignment out. Next week was supposed to be spring break, but the Board of Education made those changes where we actually officially will still be in school so that we can get out May 22nd as we finish out the year with online education completely. So we're still in school next week, but that being said, I am getting a little burned out of staring at my computer for 10 to 12 hours a day. And so I will not post a folder for you guys on Tuesday. There will just be one folder post from me, and that will be next Thursday. I may communicate with you before then. It may be a remind message. But in terms of work, there will not be a work folder posted for you guys next Tuesday. Otherwise, the rest of the information is there. Again, all you have, other than watching this video and taking some short notes on it, is to open the 4B3 EKG Part 2 assignment, and you'll work on that. Okay, guys, I wanted to just touch on a few key components of an EKG that I know that you got acquainted with through the assignment earlier this week from Tuesday's assignment that we submitted last night. But I wanted to at least go over and verbalize some things because what you're seeing here is just this picture of an EKG wave. First, the terminology is interchangeable. More common than not, I hear the terminology EKG. It stands for electrocardiogram, and cardio starts with the letter C. So you're like, shouldn't it be ECG? ECG is also very commonly used. Electrocardiogram with the C, ECG, that is the English spelling of that, which you would think that would be the only way we'd hear it here in the United States. But EKG is the Dutch or German spelling electrocardiography with a K for cardio. So it's a small little difference, but EKG and ECG mean the exact same thing. They're used interchangeably. You say it however you want to. I generally just say EKG, but it's totally up to you. When we look at this, what we're looking at is actual electrical activity of our heart. Our heart controls its own beat, meaning we don't have our brain every time our heart needs to beat. Our brain doesn't send a signal saying, beat now, beat now, beat now, over and over and over and over again. That'd be a lot of neural connection and a lot of work for the brain to coordinate with the heart every single time that it needs to beat. We're talking 60 to 80 times per minute just at rest. So the heart itself initiates and runs its own heartbeat. So it's called a myogenic pump, meaning that it initiates and regulates that heartbeat. So when we think about our resting heart rate, if you were to sit right now and take your radial artery with your other fingers and count how many times it beats as you sit watching this enthralling lecture, you're probably still at rest and it's probably pretty low. But what you'll see if you count, how many beats in 30 seconds and multiply that by 2 to get your beats per minute, that is just a continuous actually just rhythm that part of our heart controls. Okay. And I'm going to show a graphic down below that's going to connect the heart to this electrical activity. What we see here is an overall one cycle of a heartbeat. And what we want to keep in mind is that the heartbeat, when it beats, we want to think of that lubbed up, lubbed up, lubbed up. Every time our heart beats, it's actually two little pumps that we hear. We hear boom, 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 boom. Well, those two pumps, that is first the top of our heart, the very top, and I'm pointing at it right now in the air, that's invisible. But you'll see that first lub is the atria, the right and the left atrium pumping to contract to push blood down into the right and left ventricles. The second beat, the dup of lubbed up, is the ventricles contracting at the same time. So right and left ventricle, both contracting to push blood out. Right ventricle sending blood to the lungs, left ventricle sending blood to the body. And so all that is electrically controlled. And you're like, that's weird. I'm not plugged into anything. How are we electrical? We're electrical through the movement of ions. Ions are those positive and negative charged atoms, if you will, that are short or have too many electrons to give them that charge. The movement of lots and lots of those charged ions across a cell membrane quickly changes the charge inside of a nerve cell, for example, or a muscle cell. And by that change, that actually leads to contraction of muscles. So even if you voluntarily want to just flex your bicep right now, by flexing that bicep, by your brain's telling that bicep to contract or to shorten, there's actually loads and loads of ions that are going to move inside and or outside of nerve cells and muscle cells to cause them to contract. So we are electrical beings by nature, whether it's voluntary contraction of a bicep or involuntary control and contraction of the heart that's controlling blood flow to our entire body. So when we look at this EKG, what we do want to know first and foremost is just the different areas are labeled by the letters P, Q, R, S, and T, which is nice. They're in order. And they go directly from left to right. And I'll show specifically what each of these mean in a moment. But what I kind of see in an easy kind of memory for me is every other letter is an upward spike. So starting with P, we have this little bump here, or an upward movement. When we have an upward movement of this graph, we call that depolarization. Depolarization means that something's contracting. And so I would write that down. I would make sure that you're like, okay, I got to know these letters. I got to know P, Q, R, S, and T of an EKG wave, of one pumping of a heart, or one beat of a heart. And then every time I see an upward bump, there is a depolarization or a contraction of things. And we're really probably going to focus on the contraction of P and R here. So we see an up for P and then a down for Q, an up for R and a down for S. And then finally, what I refer to as kind of the return to ready for the next heartbeat, which is T. Okay. And so what we see here as I scroll down is a little bit more of a specific breakdown of what's going on in our heart at each of these different points. And this is something that I do want you to focus on a little bit more so for a next stage of understanding. As we look at one heartbeat from P all the way through T, the P wave, that little bump right there, that is depolarization of the atria. Again, I want you to just, for now, let's connect the word depolarization to contraction of that part of the muscle of the heart. So when the atria depolarize, the top of the heart is contracting. And so I even have that picture down here below. So where you see a little purple in the shading, that is the top of our heart, or the atria, contracting. And what that's controlled by is something that I want you to write down. It's called the sinoatrial node, and it's labeled as such right here. You're rarely, if ever, going to call it the sinoatrial node. You'll call it the SA node for sino and atrial. The SA node is the start. It is the rhythm or the pacemaker that's naturally found in our heart, and it's found on the outer wall of our right atrium. So right up there where we see that yellow dot, that's the SA node. It's a collection of cells that actually control their own rhythm, and they send out a signal to the heart. And so that signal starts with the SA node. And when the SA node gets electrified, if you will, it will cause the atria to squeeze and push blood down to the ventricles. So what we see, that little bump there, is the bump of the right and the left atria contracting. They are depolarized by the SA node triggering that. Notice, guys, it's just a little bump. The atria are very thin wall muscle. It doesn't have to pump the blood very far. It just has to give a little squeeze and push the blood straight down with the help of gravity into our right and left ventricles. So that's just a little bump, okay? Now, what happens so that we get the lub-dub of the heart? What happens there is a separation of the atria contracting and then the ventricles contracting. If everything contracted at the same time, our heart would not be efficient. It wouldn't really serve a purpose to have 4 different chambers. We wouldn't get blood efficiently put out to our bodies. So we have to have the atria contract and then like a brief pause. So what happens, I want to give you our next structure, is the atrioventricular node. And you can see it's just a little bit more towards the middle of the heart, and it's making its way a little bit closer to the ventricle. So the right ventricle is down here in blue, and the right atrium is up here in blue. The AV node, the atrioventricular node, so it's kind of like right sort of between the atrium and the ventricle on the right side. That's the next spot where there's a collection of cells. And they're going to get the message that gets spread from the SA node. And when they get the message, meanwhile, the atria are contracting. When the AV node, those cells get that message, they actually delay. They're like, quick pause. And they pause for about 1/10 of a second. And that pause allows both atria to properly squeeze and get blood all the way out of the atria into the ventricles. Once that delay happens of about 1/10 of a second, then the message gets spread further. And you can see in purple, the spread of that message actually heads right down the center wall of the heart that separates the ventricles. And that wall, you may remember, you maybe have your diagram out, that is the septum. And that septal wall carries all these electrified messages and sends it right down. And then that message curls around the ventricles. And so what we'll get when all that purple is highlighted in this last picture is we'll get the ventricles contracting. And again, that's going to be a separate contraction than the atria contracting. So we get, again, lub-dub, lub-dub, lub-dub. And that's just atria, ventricle, atria, ventricle, atria, ventricle. And so as we look at our EKG, the big spike, which we call the QRS complex, that's the entire portion of the ventricles contracting. Notice how much stronger that peak is than our cute little peak that was the atria contracting. Our big old peak here, that's our right and left ventricles that are so much thicker and stronger and have to send blood out of the heart to the lungs, up to our brain, down to our toes, out to our arms, etc. That's got to be a stronger beat. So the ventricles are that stronger muscle that are going to send blood further out to the body, so we see a stronger peak. That's all 3 of those together, the QRS complex. Okay. So again, depolarization of the atria is P wave right here. Depolarization of the ventricles is the QRS peak or complex that we see right here. The other term I want you to be familiar with is not depolarization, but repolarization. And the way that I have always remembered repolarization is it's like return to ready. When we see ventricular repolarization happening for this little bump T right here, what that's doing is returning the ventricle muscle, the movement of ions to the right sides of the cells to prepare the ventricles for the next depolarization or the next wave that would come along with the next boom, boom. Okay, so depolarization is contraction of those muscles. Repolarization is returning those muscles back to resting so they're ready for the next contraction of the next heartbeat. Again, it just keeps happening, okay? And so again, this graphic down below gives you another look of the exact same thing we see up above, but it's connecting us to the heart of the picture. So I really want you to use these graphics, jot your notes down so that you can clarify terms like P, Q, R, S, and T, and making clear for yourself what depolarization is versus repolarization, and how to know what parts of our heart are beating at these different parts of one cycle, one electric cycle of a heartbeat that we see in this graph right here, that electrical impulse that we see. So what you guys are going to have for your assignment today, guys, is you're going to get onto your computer and you're going to go into a virtual lab where you'll get to see different EKGs, and it's called an ECG lab. But you're actually not just going to only see a normal ECG. I'm going to assign you 4 specific types of situations or issues that come up with a heartbeat, things like tachycardia and bradycardia. And you're going to research those quick little blurbs about each of them so you can learn, when an EKG looks wrong, there's probably something wrong with the heart. And so a cardiologist becomes a master of being able to read an EKG to determine what is potentially wrong with this person's heart. You're going to get kind of an introduction to that. Again, if you have problems getting Flash Player to run on your computer, very often when you try to run something with Flash, at the right end of the address bar will very often be a red dot. If you click on that, you should have the option to either just allow Flash to run, or you might have to click on a word like manage, where you'll have to maybe go to a new page where you'll just click that will say, allow this Flash Player to run on this website. When the ECG is running for a certain type of situation, it'll just be cruising by and it'll tell you what the heartbeat is like. If you just want it to stop, which you'll need to do to take a screenshot of it for the assignment, all you have to do is move your cursor over that EKG. And maybe I'll just show that real quick before we break away here. Let's see if I got this. So for your assignment, you'll do part 2. It'll look a lot like part 1. You'll scroll down, you'll scroll down, you'll scroll down. And there on page 4 in highlight, that's where you'll start today's assignment. You'll click on this link for the 6-second ECG. And it'll bring this up. And it should work for me because I've been using it. Again, if you have issues with Flash Player not wanting to run, you probably have Flash. If you've done things on your computer for online school up through these last 4 weeks, you probably have it. All you're going to click on is Learn. If you click on Game, that's you just playing and trying to understand what's going on. And just kind of challenging yourself. But if I click on OK, it's got all these different types of situations. You're not going to go through all these. You're going to be assigned 4, and then you're going to choose 2 that you're curious about. But a normal heartbeat is just a sinus rhythm. And so it's showing me a normal sinus rhythm, a normal EKG. A new wave is created every time the heart beats, and it's actually telling us this person's heart rate, number of beats per minute. It's giving me a description of what a regular sinus rhythm is right here. And so you're going to jot a thing or 2 down about that. But again, when I want to stop this to take a screenshot of it, I just run my cursor right on top of it and it'll stop it. To take a screenshot of just a portion of a page, for my computer, I hit Shift Control and then the little rectangle button with 2 lines. And it almost like kind of dims the screen. And then I can click and drag from top left of the picture I want to take to the bottom right. And boom, that screenshot is taken and I can insert that into my document. If you don't have those specific buttons on your computer, just Google how to take a screenshot for the type of computer you have, whether it's a Mac or a PC. And it shouldn't be anything too terrible for you to do. If you have issues, please let me know. I think that's everything, guys. I do want to get off so you're not on this for too long watching me talk, but I hope this is helpful. If anything is confusing at all, please do not hesitate to ever contact me. Guys, I'm happy to help, whether it's just a message back and forth, or if we need to have a quick Google Meet to just face-to-face have that conversation. Sometimes that makes all the difference in understanding the concepts that we cover in this class. So otherwise, guys, since this is your Thursday post and I'm not going to post any work for you guys next Tuesday, I may just send a message to say, hey, so you won't get a work folder from me after today until next Thursday, April 23rd. Hey, I miss you guys. I hope everybody's doing well. I'll continue to just try to keep in touch with you, and you can do the same on your end anytime, guys. I think that's going to be all. Have a wonderful day, everybody.